Pause the video and unpause it when you're ready for me to go over the do now. Leave it paused when people come in so that they can copy the objective and answer the do now question. Remember, that should be done individually for the first couple minutes. Alright, so today you're going to do a CER of explaining important factors of energy sources. You're also going to investigate the greenhouse effect through a simulation and some reading. So your do now: if a certain reaction will explode with 6 moles of oxygen, will 100 grams of oxygen make it explode? So the problem is, since these are different units, you can't really compare them. So the first thing you need to do is convert either the 6 moles to grams or the 100 grams to moles. That way you can compare them. So if you do the 6 moles, you got to cancel out moles. You multiply by the molar mass, because that's how you go from moles to grams, and you get 192 grams O2. So what that means is that you would need 192 grams of O2 to get 6 moles and explode. Since you only have 100, it won't explode. You can also go the other way. 100 grams is how much you have, but how many is that in moles? So now the grams goes on bottom. You would divide by the molar mass, and so you get 3 point whatever moles. Well, this is barely half of 6, and so no, this will not make it explode. All right, so that's the do now. Quick announcements. Projects were due on Tuesday. Phone calls will be coming home if you have not turned it in yet. All right, this is your warning. Class discussion for the project is on Friday. It's a short period, so that's all we'll be doing. You'll be assessed on how well you use evidence and reasoning, so I highly recommend maybe writing down a few quotes to use for evidence so that you can be prepared. And then again, Unit 4 action plans are due by Friday. You can turn them in sooner. So the first thing we're going to start off with is this CER that I told you about on Monday. So this is test expectations. You're doing it on your own, not as partners. It should be silent, phones away, all that stuff. Write it on a separate piece of paper. Make sure you put your name at the top. Duh. This is open book and open notes. I hope you prepared your evidence because you will only have 30 minutes. So interim teachers, you can set a timer and you will not get extra time. So after 30 minutes, collect everyone's paper and leave them for me for when I come back. Go ahead and pause the video, and once those 30 minutes are up, you can restart the video and I'll explain the next section. Okay, so you should have picked up these worksheets on your way in. It says FET greenhouse effect photon absorption. Please make sure to put your names at the top because you'll turn these in at the end of the period. There's a link to the simulation on Google Classroom. I tested it on a few computers. It should work. So go ahead and get on the Google Classroom and then follow the directions and make sure you record your answers on the second page. I'll briefly go over the answers at the very end. It should take you maybe 15-20 minutes to go through the simulation and then 5 minutes to go over the answers with each other. Okay, so you can pause the video now, and once you've everyone had time, you can unpause the video and we'll run through some discussion. If you finish early, you should read the pages at the top. Okay, so my little drawing board's not here, so I'm going to try to type and see how that goes. So methane, carbon dioxide, and water vapor, all three of these, absorb and re-emit. Re-emit infrared. Okay, so you should have seen them kind of suck up the red and then shoot it out. All right. Whereas nitrogen and oxygen, they have no response. The red infrared just shoots right through them and doesn't do anything. And this is actually what we saw for all of them for visible radiation. So the visible radiation goes straight through every single one of them. This means that it's not absorbing light at all. So all of these gases are colorless and they're all transparent. You can see straight through them unless you're somehow using an infrared eyeball, which our eyeballs don't see infrared, so we wouldn't notice. Okay. when you actually did the simulation for the greenhouse gas concentration, you should have found that when there's no greenhouse gases, you have a very low temperature. I don't know the actual temperature it goes to. And when you have a lot, you have a high temperature. And then a greenhouse gas concentration in between will have a temperature somewhere in between. So the more greenhouse gases, the higher the temperature it appears. All right. If you haven't talked about these in partners or as a class, then go ahead and pause and talk about these briefly, at least hear from a few people before I discuss it. Okay, so you've had a chance to discuss, you unpause the video, here we go. Which gases absorb and emit infrared radiation? These are called greenhouse gases. If you go back to our data, these three were the ones that absorbed and re-emitted infrared radiation. So these are our greenhouse gases: methane, carbon dioxide, and water vapor. How can you use your answer to question 1 to explain the approximate temperatures with different greenhouse gas concentrations? So as there were more greenhouse gas concentrations, the infrared radiation that we saw shooting up from the Earth wasn't able to go straight up. It sometimes looked like it was bouncing back down. Well, it wasn't actually bouncing, it was getting absorbed and then re-emitted, and sometimes it would actually get re-emitted back up, whereas other times it would get shot back down. And so if it shoots back down, that means more energy is returning to Earth, which increased the temperature. So number 3, what impact on climate would you expect an increase in carbon dioxide or methane to have? Well, if there's more carbon dioxide and methane, that means more infrared being absorbed and re-emitted and going back to Earth. So you would expect the temperature to increase. Okay. So now, through the magic of editing, I'm going to attempt to insert these YouTube videos. There's one on CO2 absorbing infrared radiation. I'll try to put a little pause in between so you can pause before the next video. I just want you to discuss with each other, what's the point of the video? What is the video trying to communicate to you? Okay. So, there we go.
I can show you how carbon dioxide affects Earth's climate using this heat-sensitive or infrared camera which is purring away here, and a candle, this glass tube which is hooked up to this rather large canister of carbon dioxide gas. Now if I light the candle, you'll see that on the monitor the camera picks up the flame perfectly. Look at that, the hottest parts are glowing white. Now watch what happens when I turn on the carbon dioxide. Just keep your eye on the flame. The gas is invisible, so you don't see it fill in the tube, but as it comes in, you should see the candle start to disappear. There it goes. Look at that. What's happening is that the carbon dioxide in the tube is effectively trapping the heat. The candle's warmth no longer reaches the camera. Instead, it's absorbed by the carbon dioxide inside the tube. That's exactly how carbon dioxide works in the atmosphere. It traps heat, preventing it from escaping into space.
The heat's on back at Ice Station Central. The greenhouses are ready and the Jamie Ice dolls are chilling out. But can their small-scale greenhouses back at M7 really produce a plausible greenhouse effect? The guys head off to consult an expert at UC Berkeley. And after a little demonstration showing the power of ice...
Oh my God!
It's down to business.
So I've heard a lot about people making models to predict the future of global warming. And with all of the complicated systems on Earth, wouldn't that be a little difficult?
We can do experiments on small scales in the lab. We can make observations on a global scale. But you're right, it is hard to replicate in a 3-foot by 3-foot chamber. It's a challenge. I think it can be done, but it's a challenge to replicate that.
Challenge? That's Mythbusters' second name. And back at M7, it's time to commit the Jamies to a watery grave.
Poor Jamie's looking at you like that.
That ice-cold stare.
Try working with them all the time.
Everything has to be kept identical in this experiment.
That looks good right there. So that's 1,570 foot candles. So let's try to get all the lights so that that amount of light is going into each greenhouse.
Okay.
Accurate thermometers are essential
These thermometers measure 1/10 of a centigrade.
to make sure it all runs to plan. The guys have called in Manish Gupta, a gas monitoring expert from Los Gatos Research. The Earth's CO2 levels stand at around 350 parts per million, and methane a tiny 1,800 parts per billion. But amounts that small are no problem for this gear.
For methane, it's in the part per billion level, and for CO2 in the part per million level.
So now they can up the greenhouse gas levels in minutely accurate increments. And once the gases are in, everyone can chill out and watch ice melt.
Let's start melting some Jamies.
M7, it's the big freeze. The temperatures have been steady in the control greenhouses, while,
The methane and the CO2 have been a degree higher consistently.
but after 3.5 hours withstanding the heat, the Jamies finally crack.
So we've let the experiment run for 4 hours, and I think from the results that we're getting, we can come to a conclusion. Both the methane and the CO2 greenhouses remained hotter than the control. Throughout the whole experiment, it looks like the gases do increase the temperature inside the greenhouses.
The CO2 greenhouse stayed steady on 24.8 degrees Celsius, the methane on 24.9, and both the controls were consistently a degree cooler.
I think that this is showing that CO2 and methane are major culprits for global warming.
All right, so the results from the global warming experiment were pretty conclusive.
Yeah, the greenhouses with carbon dioxide and methane stayed consistently warmer than the control.
Yeah, it was almost 1 degree Celsius warmer the entire time.
All right, so this one's confirmed?
Confirmed.
Alright, so hopefully I successfully edited the videos in and you watched both of them and you got a chance to discuss with each other. So the last thing we're going to be doing today is doing some book reading time, so this should help cement what we hopefully have learned about greenhouse gases and carbon dioxide and whatnot. You're reading pages 356 and then 359 to 362. You can skip page 7 and 8. And then you need to answer questions on 363 and 364. All of them. You don't need to make your own study guide though. Anything you don't finish is homework, and I'm going to be collecting it next Tuesday and Wednesday. We have Monday off because of Jason and Alejandro's birthday, I assume. Okay, so go ahead and pause the video. Oh, I should have said, this is individual, however you spell it. Okay, by yourself. Okay. So no partner reading here. You're reading on your own. Should be silent. I hope you get a lot done and are really productive. Have a good day, and I will see you tomorrow maybe.